Yes, hello to everyone and welcome to the day session.
Okay, 16:30. Let's get started. So I should be, yep, I can click the presentations. Hello to the webinar. My name is Alexander Trost from Cloudical and Jolland.
Hello everyone, my name is Julian Budruge, also from Cloudical.
Yeah, so let me get straight to the topic we have today. We're going to talk about Kubernetes overview of network policies. For the agenda for today's webinar, we basically have, as well, the last few times, we have a short recap of what we talked about in the last webinar. We talk about network policies. They're about the points concept, examples, useful tools, and specification. And as a last point, last minute notes. That's more or less kind of like a, well, a few points you should look out for when looking into network policies. Okay, the recap from before when was it, 3rd of June? Yeah, this is right on the screen. Pod security policies. For summary, just like the two quickest, well, most important notes if you think about it. And the first would be that the first policy by name that matches for a pod, that one is used. And be sure to take a look at the pod security policy specifications in the Kubernetes documentation. And well, for the control aspects for the pod security policies, we more or less simply have just a few of the most important points where there's privileged, host network, host ports. We have volumes, we have run as user, run as groups, and so on and so on. I'm not going to mention all of them, especially the one with the run as user and FS group. If you're an application operations person or developer, those are the ones which are the most important. And probably Jolland can say a few words again about the privileged and the host network part.
Yeah, sure. Yeah, with the privileged, if you provide the pod with this attribute, then the pod would be able to access all the devices on the host it is running to. So this is maybe something you don't want to have from a security perspective. So you would be careful, or you should know to which pod you are providing such an attribute. The same is true for host network or host ports. It will give you the possibility that the pod can access the network of the host. It can access the loop network so that it can actually eavesdrop in the network communication of the different pods that might run onto your machine, so that it can eavesdrop communication that it's probably not allowed to do so. So for more information on that, I would suggest to you can listen to our previous talk, to our previous webinar. We record them and we put them onto our YouTube channel. So just feel welcome to listen to them. And if you have any specific question to any specific point, just feel free to address us. You have our emails, you can contact us, or even whatever it works for you, or even in another session, you can join and maybe ask specific question to that if times allows.
Yeah. So be sure, if you want to check out one of the older webinars we had, we have recorded, and also some completely other topics regarding cloud, especially, feel free to check out the Cloudical YouTube channel. Okay. So finally, moving on to the topic of network policies. Well, what are network policies? There isn't really too much to say besides that they're basically, well, they're basically like a traffic control. It's kind of the same as you have with when you're driving a car with the traffic control there, with the traffic lights and so on. With the aspect there that you have it for ingress and egress traffic. That, well, the same goes for normal traffic to a certain extent. But for the application side, that's more or less like the thing that you would need to look into for your application. If you can simply add traffic control, so to say, network policies to your application. From certain standpoints with security, it can make total sense to have basically firewall rules to a certain extent in Kubernetes between your pods, but it can also be misused. I'm going into that a few slides further down the road. So network policy simply, you can control traffic. You can control which pods can talk to which pods. You can control which namespace, and well, with that, which pods in that namespace can talk to which other namespace. And you can not only do that in regards to ingress, so to the pod incoming traffic, or even from the application, then from the pod outgoing traffic. Those are the two ways you can do it. You can do it in an ingress and egress way. Some of you might have already heard about ingress in regards to ingress controllers, like the Nginx ingress controller. That's kind of, it's basically from the word side, well, the same part. It's about into the cluster, like especially looking at ingress controller, it's about getting traffic into the cluster. Though ingress controllers, at least in regards to like Nginx and so on, don't have anything to do with network policies. Network policies are a separate thing, which are in like most cases implemented on a further level, on a lower level than your ingress controller, like Nginx, for example. So don't get that confused. It's separate things. It's just the same word, as in the end, it's the same thing. In this case, it's basically getting traffic into the pod and not in a general sense into the cluster. So keep that in mind.
Yeah, so this is a good point that you make there, Alex. You make this distinction because many people just get confused about that, and this is very good to make this distinction to see that actually with the network policies, you are restricting or allowing as necessary the communication within the pods and within or with other endpoints resources within the cluster. But nevertheless, if you don't have any ingress controller, then no traffic can enter your cluster at all. So think of it as two layers. So in order to allow traffic into your cluster, you need this ingress controller. And in order to allow still this traffic to reach one of your pods, you need to specify the correct network policy rules so that this traffic can be get into that pod, or it can get outside of that pod.
Exactly. Picking up there, we should look at the use cases for network policies. And even though it's, well, from a list perspective, it's at the top of the list, so to say. If you're using network policies to, well, do some kind of firewall replacement, like in some weird way, you're probably not necessarily doing it the right way. Normally, you should only worry about traffic inside of your cluster. So it's technically still kind of firewalling, like it's basically firewalling pods, but I have heard about a bunch of methods where you can basically change the host firewall and such, depending on the CNI you're using, in regards to external traffic as well. So it's more or less like you have to see if you can use it as a firewall replacement, even on the total low level of the host that you're running on with your applications, with the pods on Kubernetes there. For the second part, for security, it's not really making anything, well, any more, better in regards to security. If, just a second, if you're basically just firewalling all the applications between each other. Like, yeah, obviously this is restricting access to the pods and might, reduces the attack surface an attacker has if they're inside a pod that, well, in a rogue pod basically. But in itself, it's more or less like a, well, if you don't have any authentication on your services and you just firewall it, like, well, yeah, that's making it more secure, but you're not fixing the actual problem. Like, there's no, not really, like, you can, I said, it's making it more secure, but it's like you fix the problem at the wrong end of the line, basically. So, well, you probably can say, you can talk about 1,000 stories there.
Yeah. So yeah, that is true. Also, again, this is a very good point to distinguish. When it comes to security, it's not, there is no certain one tool of doing things secure or securing your cluster in Kubernetes. So you need to think of security as a continuous process. And especially when even looking just only to Kubernetes cluster, understand that there are different layers where you can secure your clusters, and network policies are one layer when you can add more security when it comes to communication within your cluster or even outside of the cluster. But as Alex is making here a very good point, this doesn't make you believe, you shouldn't believe that not anyone now can access that machine or that pod or that application running on that pod, because you just are restricting communication to that from a specific range of IPs or from specific machines or ports. If you haven't put any authentication, so anyone who is able to come from that specific range or is able to know from which specific range you have allowed traffic in or to outside of that pod, it would be able to access that information. So think about it as different layers where you can restrict and you can improve the access control to the communication layer.
Yep. So, yeah, well, the same kind of goes with for the third point, your isolation. Like, well, you can use it to further isolate your application, but keep the second point as we had it just now in mind. Like, there's, if you have an application which basically accesses no other services, but for example, just write some data to its local storage or to like a persistent volume attached to it, that's the point where it's where it totally makes sense to completely firewall it off. But still, as we had it with the second point, a firewall net doesn't necessarily guarantee 100% isolation as well. Like as we have it with containers, there can always be some kind of issue or some rule that's being wrongly created or something. So, yeah. Okay, so I don't want to go into, too many details. Like there's not too much of a point of going into like heavy examples here. The thing is, in the end, they do what they advertise. You have control. You can control which pods talk to which pods. You can control which pods other pods can talk to, and even go as far as controlling if the pod can access the internet and so on and so on. Like there's cool possibilities like that. But in the end, especially if you already have a running cluster without network policies, are you up for the task? Because it's not just that you flip a switch and bam, that's it. Because you need to make sure that every application, if you want to do it really tight, you need to make sure that every application that talks to every other application in the cluster has the right permissions, the right network policies in place for that to continue doing so. That's the part where it's, are you up for the task? Because if you have a cluster running, you can break it, and I can definitely tell you can and will cause downtimes when you start using network policies. To do any kind of misconfiguration. well, you might be really, really lucky if you just start with network policies and directly try them out, and nothing breaks. But still, to a certain extent, you need to make sure that everybody that's using the cluster, and especially while deploying applications to your Kubernetes cluster, is aware of the fact that you're using network policies. Otherwise, there will definitely be downtimes because of that. Or people going like, why is my application not being able to talk to my database anymore? Like, what's going on? And that's exactly the point where you need to be sure that you are up for the task, that you're able to talk to everyone that is involved in the cluster and make sure that they know what they're doing with you together there as well. Well, if you start with a new cluster, with a cluster, don't worry, the new is getting delivered tomorrow. If you have a new cluster, it's obviously, much easier, because then you start with every application needing to already create network policies and such. But it doesn't make it easier. Like basically the 2 points I've mentioned there when you start with a new cluster, they don't disappear for the first point with when you already have a cluster running already with stuff on it. It's not making it any easier. Because, well, those 2 points for if you have a new cluster, you need to have concepts in place. You need to make sure that you either do it centralized or decentralized in regards to the network policies. You need to have concepts and policies, and ironically, policies for network policies in some kind in place. Because I'm personally exactly one of those people to at least, like, guys, we have a deadline. We need to get it done. And you're saying like, guys, we need to make this, nice and not just a rushed way. But then often enough in the actual real world, there's no time to fix it or like work on it further to, like, for example, fix the network policy. And there will definitely, if you don't have policies like that in place, or like a central place where it is controlled, that there will definitely allow any policies, which are not cool, because you normally really want, if you want to use network policies, you at least want to clamp everything down tight. That's only the ports and pods for the pod that the pods, you get the point. You have the pods to talk with the other pods, so you want to make sure that only the pods talk with each other, and maybe even going further, only the 1 or 2 pods which are important for those pods, and for those pods are available each by them. Not that some pods can access ports, which they should not do. So be sure that you look into, that you make sure that you're up for the task. Because as I said, you need concepts, you need to have an idea if you do it central or decentral policy management and creation and all. Like, you have to make up your mind in regards to that. Both parts of, like, the central and decentral part have advantages and disadvantages, as everything, who'd guessed it. But, you simply need to see what is the most fitting part for your environment and, company/environment cluster, whatever you want to call it there. Now.
Yes, exactly. I mean, you're making again a very good point here when you're putting confronting these to each other. So what is actually the use case you are? So you can definitely have 2 use cases. Either you are running a cluster and you have the task to restrict your environment with respect to the communication, or you are using a new cluster, and again, your task is to restrict the communication. As Alex put it, if you start from the first use case, you should be aware of your communication matrix, meaning what is talking, or which pod or which application is talking to which application or to which backend. And based on that communication matrix, you should be able to derive the correct network policies. This is not an easy task, as we know for sure from the practice, especially if you haven't documented your communication matrix very good. So from there, then you can derive the correct network policies and implement them, and hope that your downtime would be as low as possible. While you're starting with the new cluster, then, start documenting your communication matrix. from the beginning, and then from there deriving the correct rules. And maybe there the advantage you have is that you would test the rules maybe before going into the production, while in the first case you are
definitely
leading the production. So
production.
this is again a very good distinction here that you have to keep in mind.
No. So as I said, like I'm not going too technical into this topic. Like there's not really a point, as with most topics in Kubernetes, by me going ahead and throwing YAML file after YAML file at your head. So a repository I can simply recommend is from Ahmed B, the Kubernetes Network Policy recipe repository. It contains a bunch of examples for applications in regards to network policy. So it's, if you want to get started with network policies, it's worth checking it out. Let me also go ahead and, well, for example, even with a nice diagram, so you see where's the traffic coming from and like which pods would be affected, or well, which containers in the end of the pods. It's pretty cool. To even take one of the examples he has here as a demonstration, as well as example. It's, you know, in the end, it's just YAML. It's just a bunch of YAML. But even if you have one part of what is shown here at the wrong position, you screw over your whole cluster, possibly. Like you're restricting traffic to the wrong pods, or you know, you're breaking existing policies and such, and it can definitely go wrong. For that, because you know, you just want to make sure that there's not too many issues with your network policies when you use them. There's a tool from Innovex called Illuminae. You know, it's basically it's to bring light into the whole situation, please. Not the, well, yeah, we're out of triangles for this presentation, so please. The thing is, well, seems like a pretty cool tool. The Innovex people there, what was his name? Damn. Now I want to shout him out because he was one of the creators of the tool, but I forget his name. Damn. I think Johannes was Johannes Schreiber. Well, it's a cool tool. It's a cool tool. Check it out. You can use it to test network policies. But also, as always, you know, check out the specifications. Check out the documentation in the Kubernetes documentation as well, because there's always a bunch of things, especially network policies, to watch out for. And especially if you're on a bit of an older Kubernetes version, as there have been like changes where the selectors are not OR gated, but now AND gated and such, you know, and it's exactly such things which will cause you trouble when you begin. So, well, check out the documentation on the Kubernetes side and the specification, and also, well, check out the tool. It should maybe help you, depending on how you deploy your network policy. So, well, shout out to them. Well, let me just jump to the last minute notes there. It's like, you know, I said I can throw YAML examples and stuff around. The point is you can restrict traffic going into pods and even going out of pods. That's the whole thing in the end. You can do that by namespace, by just labels on pods, on certain pods and such. You know, cool thing. You can restrict stuff. Awesome. Wow. But the thing is, it sounds cool. It's awesome. Woo, restricting traffic and such. But there's a bunch of things you need to watch out for, as we already had, like with, if you do a wrong policy, you can possibly break the whole network because everything's not allowed to do any traffic anymore or something, or you disallow your operators in your Kubernetes cluster to talk with the Kubernetes API and such. You know, it's such things which you can accidentally break. You might even not notice till, well, when it's too late. With the last minute notes, well, if you have, no matter, well, no matter what network you have, well, no, not necessarily. If you have a CNI the container network thing that does the network between the nodes, like Calico, Cilium, and all those cool things, cool projects. To a certain extent, you will always lose at least a bit of performance in your cluster network. You will always lose a bit, because it's simply looking at it for the people that know what IP tables is. It's basically firewall rules under Linux. Looking at that already, like the kube proxy that does the service part, depending on what CNI you're using, like using the kube proxy is default, but there's already ways with like Cilium to not use the kube proxy. But for a kube proxy in a default mode, which is using IP tables to do like the service routing and stuff, it's, well, if you have a bunch of services, and I'm not talking about 100, I'm talking about like 1,000 or 2,000 services. At latest at those points, you should more and more see that the performance is more and more slowly like basically diving down, because also at one point, like it's just full in quotes, like IP tables is not the problem necessarily there, but just the concept of how kube proxy did the IP tables, how it created them and managed them is a bit limited, and it's not really possible to improve that. So there's, just for the people more of, well, as an X course right now here, kube proxy with IPVS mode. If anyone maybe, well, check it out. Cool mode. It's not using IP tables anymore. Has as everything some advantages, some disadvantages as far as I'm concerned. But yeah, to come back to the network policy part. Some networks, like, well, some CNIs, they have certain possibilities to do even much more than network policies. Meaning that, for example, Cilium can do not just on a basically IP to IP layer / port to port layer, without managing the OC layer name, a number. It's even possible with Cilium to do it on level 7 at the application layer. As far as, at least for Cilium, I've worked a bit with Cilium in the last few weeks, so I know a bit from that. You can even control Kafka access, and they have, like, there's a bunch of, like, a few more applications which you can at the level 7 basically restrict, which is great, because some of those applications, I think there might have been, I'm not sure if Elasticsearch was necessarily in it, but already something like Kafka, being able to write down a policy in YAML and applying it. Well, don't forget the points we had earlier. Security, it's still good to have passwords and such, but it's good to have an additional separation there, depending on how, if you, for example, you have one environment, not just for dev, for testing, but also for quality insurance, and, well, assurance. So, well, so that's, well, already kind of the second part there, that some CNIs can already do more than just network policies. They can do, well, kind of application level balance policies. That's not a thing. For most CNIs, they're just called some way, like in Cilium, it's called Cilium Network Policy or Policy or something. I forgot the name there. So, but you know, you get the point. You have some YAML you need to apply. It, you know, does its thing, and well. For one sub point, yeah, with this, you should take service meshes into account. If you use service meshes, like, well, especially something like Istio, where you can already also restrict who can access which parts and such, you definitely, I want to say should, but you definitely must take this into account. Because where's the point in you adding 5,000 network policies, which slow down your network by, let's say, I think I'm even pretty light on a percentage here, but like 15%. And the service mesh is also, again, putting on like 10% of a dive on the performance. It might be an issue, but it might also just mean that, well, just use service mesh everywhere and not bother with network policies, depending on your use case, if that covers it. Yeah. And as the last one, it's more or less just the typical well, you create network policies, whoa, cool, but you should also check up on them. Like maybe someone edits them manually. They shouldn't be able to, depending on, your setup, but maybe, someone changes something, or, it continues to work or something, and at one point it breaks because there has been a change or something. So be sure to have, as we had with central or decentral place from which they are applied, well, managed, simply created, managed, and so on. Yeah. Well,
so
that's it from the topic.
Mostly at the end. So maybe just to sum up or the main point. So we talked about network policies today. We know that network policies are there to specify the communication between pods or from pods to other endpoints into your clusters. You can use labels to select or define rules that applies to this pod, or the pods that you want to apply, or the namespaces that you want to apply, the network policies that you have written in order to restrict the communication, because by default, the pods in your namespace will accept traffic from any source. So be aware of that. Try to isolate your communication matrix with implementing the correct network policies, depending on the use case where you're starting, as Alex put it very nicely. Be aware that network policies are additive, meaning that at the end of the day, the union of those rules would be actually what is being applied at the end. And also to the point, if you are writing network policies, be aware of the CNI plugin that you are using, because if you are using whatever CNI plugins that do not support network policies, then these network policies are not being implemented or are not being applied. This is the one point. And the other point is the performance, where Alex was discussing about. So think about it of using maybe CNI plugins that are providing you with packet filters, like the extended Barclay packet filter, which is implemented by Cilium, that can do high performance packet filtering on a very low level in the network stack, because it's looking at the packet at the same time when the packet are received into your network stack. So
not like through 5 chains or something till when it's, well, it's having its point why it was and there is like that, like it's not necessarily bad, but for that case, for high performance states, well,
so exactly that. So if you want to improve performance, or if you want to have that, and also in the combination with the IST.io, think about it, that writing network policies, it doesn't mean that your communication is going to be secure. So by meaning with that, so introducing service meshes, you also would be able to authenticate and encrypt your communication between the pods, or from pods or into the pods. So this combination will provide you, again, another layer of security. So think about it of different layers where you can add security, and where the network policies are actually lying, so that you can assign them correctly, where they apply, and what are the capabilities so that you are winning by using the network policies. So with that said, I think we have it for today. And if you have any questions about that, then Alex and myself would be happy to answer them for you.
Let me just go ahead and try to find my Zoom control panel. Damn it. Do you have the chat open and the questions? Because
yes, I do have the chat open, and I do have also the questions open. Please, for the moment, it doesn't seem that there are any questions so far.
Ah, there we go. If you have questions, so no.
Again,
Yeah, now I have the questions up.
I checked the Cloudical YouTube channel and I posted into the chat. So it seems that one or two webinar sessions that we have recorded with respect to the security topics within Kubernetes are not uploaded yet, but we will make sure that those are uploaded. So we will talk directly to our HR and marketing support so that they upload the recordings. So don't worry about that. Just visit the channel again and you might find even different videos, recordings on different topics there that you might find interesting when it comes to cloud computing in general or to specific topics into the cloud computing. So just feel free to listen to any of them in general.
Yeah. I would say let's wait the next, well, 20 seconds or something. If there are no questions, I would then say let's close the webinar for this time.
Yeah.
And don't forget, in 2 weeks we have the next one. Feel here where are they posted? On LinkedIn and such, Twitter and such. So well, feel free to follow Cloudical there, that you don't miss the announcements for the next ones. Okay, I would say no questions as far as I'm concerned. Nothing in the chat as well. Yeah. I would say,
yeah.
Have a good day, everyone. And
bye-bye.